Okay, folks, why don't we work on a few more in-class exercises that allow us to just practice writing some code in Scheme. So the first one that I wanted to try is an index function. So here's how the index function would work. If I say index A, B, C, and then I pass in the value of 1, then what I want is for this to return 1. Okay. If I say index of A, B, C, and I pass in the value of 0, then I want it, I'm sorry, that first one was wrong. I want it to return B. If I pass an index A, B, C, and I have an index of 0, I want it to return A. And then if I do something crazy like I pass in the index of A, B, C, and I pass in the value of 3, so that's sort of out of bounds, then I'm going to return the value of -1. So that's the idea of index. So what I want you to do then is I want you to take a moment to see if you can figure out how to build a simple index function. I'm going to work it out in a moment, but I want you to try on your own. All right, so give it a shot, hit pause, and give it a shot. Okay, so we're back. I'm not sure how to create comments in Dr. Racket, so how to make comment in Dr. Racket. I'm just going to Google that. Here we go. Good old Stack Overflow. Okay, so we use semicolons. All right, so I'm just going to put that right here in front of my code. Oh yeah, that's great. All right, nice. All right, and now I'm going to write the index function. Now, define index, and the first argument it takes is a list. I'm not going to say list because that actually is a reserved word, so weird things will happen. And then we have an index, but I'm calling the function index, so I'll say pos. So pos represents my index. So I have a position and an index. Now, I really like to use cond. So I'm going to say cond. And we're going to look for some different special cases. So first of all, if the list is empty, we'll return -1. All right, that makes a lot of sense. And so that's our first case. And if the, let's think about this. So that's kind of like a special case. That's kind of our base case to think about it. Let's think about the recursive case. If the or another base case, if our position is 0, so if our position is 0, then we'll return the first item in the list. And then if otherwise, else, we're going to do the following. We're going to, let's think about this. So what we'd like to do is we can sort of think of this position thing as a counter. All right, and so we're just decrementing the counter. So when the counter goes to 0, we've arrived at the next element in the list is the one that is the element that is the thing we should index at. So when we start out here with index of ABC and 0, the first element in this list is the element we want to index. All right. When our index has a value of 1, what we want to do here is we want to say, oh, it's not 0, so we'll skip this case and we'll skip this case. and we're going to hit the recursive case. The recursive case should probably call index again, but this time maybe we'll decrement our position. And we should also do something to the list, and that is we want to remove that first element from the list so that that won't be processed anymore. So we're going to say index of, okay, we've got the list first, so we're going to say rest of list. And we're going to do, so that rest of list is going to get us B and C in this case up here. And then we're going to have to change the value of position as well. So minus pos 1. Okay. Now let's see, I still have a few parens here that I've got to fix. I got to define for that. Let's say, just tab this out a little bit. That's my cond, and then I'll close my define. All right, let's try compiling that and see if I got that right. Looks good. So let's try running it. So maybe I'll try debugging so we can just observe what happens here. So here we go. Index. Let's try the first one. Well, let's try triggering the base case first. So A, B, C with the value of 0. Okay. That gives me A. All right, that worked out okay. I thought I was debugging, but I didn't set a breakpoint. Let's just test it. Index A, B, C, 1. That gives me B. All right, index A, B, C of 0 of 3. That gives me -1. Perfect. Now, there is one possibility. Just if I wanted to be super obnoxious, let's try this. Index A, B, C. Let's see if we can break it. Can you think of some ways to break it? What if I did -1? Oh, that worked out okay. Yeah, I guess that works out. We're gonna try A, and so this index of ABC -1 is going to repeatedly call in. Let's debug that one because I think that one's kind of interesting. So why don't we set a breakpoint? So let's do debug, and we will say index of ABC. We'll do 0 first. And step. Okay, I didn't set the breakpoint there. So let's do that. Let's set a breakpoint. It's funny because, for you guys, you just watched the script of how to set the breakpoint, but for me, I have forgotten how to do that. So there we go. Okay. Stop that. All right. So index A, B, C, 1. Well, 0. Okay. Okay, that's giving me my answer, but how do I insert a breakpoint? Oh, there we go. It took a little while, but I found it. Okay, so we'll pause there, and we'll pause here, and we'll pause here. Okay, so those are the possibilities. So now let's try running this again. Index A, B, C, 0. Okay, so we can see the debugger paused here. The value of list is ABC. The position is 0. So this is going to evaluate to true. So we're going to evaluate this, and we're going to return that -1. So if we step, and we can see now with the green arrow, it's going to return -1. I'm sorry, it's not empty, so it's going to attack this one. So we're stepping here, and we're going to return first list, and now we get our result. Okay, so let's do the more interesting problem, which is index of A, B, C, and -1. What's going to happen here? Okay, so we're going to step, and we're going to check, is the list empty? Right? Well, list is ABC, and position is -1. It's not empty, so we're going to go to the next thing. Is position 0? No, it's -1. So we're going to go to the next thing. And so we're going to call index again with the rest of the list. So we'll call it with BC and position -1. So do those calculations. And now we're back in here again. And notice over here that list is now BC and the position is -2. Okay, so let's keep going through here. It's not going to trigger that base case. It's not going to trigger that base case. What base case do you think is going to be triggered now as this continues to execute and execute? Think about that for a moment. All right, let's trace the rest of this. So we call again, now position is -3. We've got one element in there, just the list containing C. And we're going to call recursively one more time. And now we have a situation where our final recursive call, we have a list of 0. So we pulled every element out of list. We keep decrementing position. It's negative, which makes no sense whatsoever. But we have this nice base case here is if the list is empty, we return -1, indicating that we weren't able to find the item. So even though position is -4, that's not what's going to be returned. We're going to return -1 as the indication that, hey, we didn't find this in the list. All right. So the same thing's going to happen if we do index A, B, C with 3. So now we're going out of bounds in the other direction. We're saying, let's go beyond the list and see if we can find an element beyond the number of elements in the list. All right, so we're going to step through here. And I just want you to watch this over here as we do recursive call after recursive call, peeling off those first elements of the list. All right, and so now we're calling again. Position gets decremented by 1, and we have BC. And we're calling index again. Position is now decremented by 1 again, and we have C. Now position is 0, and we have list empty, and that will trigger the base case checking for the empty list. That means we've processed all the elements in the list, and we still didn't get the get to the index that we were looking for. So we're going to return -1. All right, awesome. Okay, let's try another one. This one actually takes advantage of list. All right, so what I'd like to do is I'd like to return a list subset. So the way this is going to work is, all right, so I'm going to say here, this is the index function. Okay. Now we're going to do a subset function. So let's define subset, and it's going to take in a list. It's going to take a start position and an end position. All right, and so let's do an example of how that should work. So if I say subset A, B, C, and then I say 0, 0, 1, I'm basically saying give me a subset of the list starting at position 0 and going to position 1 inclusive. So that should return the list A, B. Here's another one, subset A, B, C, and I pass in the index values of 0, 0. That should just return the list A. All right, so clear about how that should work? I'm hoping. So we'll scroll down a little bit. And what I would like you to do now is take a moment and see if you can figure out how to use subset. What I think you want to do is you want to pay attention to the values of start and end. And you can use that information to help you get to the answer. Those are going to be the things that help you figure out whether you're at your base case, recursive case, and whatever, possibly maybe even checking for a bad index. Okay, give it a shot. Okay, if you haven't pressed the pause button and tried this out, hit the pause button, try it out. Otherwise, you can follow along with me and see if you got a similar answer. So let's think about some obvious base cases. So one obvious base case would be when start is equal to end. That means you're pretty much done processing, all right? So when start, I need to do cond first. Cond, so when start equals start end. So when those two are equal to each other, then what we would like to return is a list that's containing the just the start value, just the single element that makes up the start value. So we could be really clever here and eat our own dog food and say, well, why don't we return an index given the list and given the position start? So think about that for a second. Does that make sense? Sure, it makes sense. What we're doing here is we're saying, I want to return the index of start in the list. So for example, up here, if I specify 0, 0 as my start and end, eventually start and end will be equal to each other. And so I'm just going to return that A. All right. So let's see. So that certainly for the base case, that makes a lot of sense. Let's think about the recursive case. What we need to do here is we want to get to a place where we're able to get the first element in the list. So let's think about this case as one to start with. So if we were able to take the first element indexed by start and append that to the other elements up to end, we'd be in a good situation. So if I were to think about that, then what I want to do is I want to take the cons. That'll let me do an append. All right, that'll allow me to construct a list. And if I say I want a cons index start, index list start. Okay, so what did I just do here? Well, let's take a look at this case, all right? So if I say subset ABC, if I take the index of list of start, that's going to give me A. Now I want to take that A and I want to append it to the other elements in the subset that I want to process. And so if I say I'd like to append that to the subset of the list of the rest of the elements. So the rest of the elements would be, well, in this case, it's going to be the elements from start plus 1, which would be B, to end, which would be 1. All right, so subset of plus 1 start and end. So let's see if that makes sense to you. So why don't we change this here, ABCD, and we'll make this 1, 2, all right? And that should return B, C. And let's see if this makes sense. All right, so we're initially going in with ABCD and 1 and 2. So when we go into the function, we're going to say, is start equal to end? No, it is not. And so what are we going to do? Well, we're going to take the index of list start. Let's just look at the processing of this one. So this will be initially subset of A, B, C, D, 1, 2. Okay. And how's that going to get processed? Well, it's going to skip this base case, and we're going to do a cons of index of list of start. So index of list of start is going to give me, well, start is 1. So index of list of start is going to give me B. So we're going to take B and we're going to cons that with subset of A, B, C, D, and we're going to add 1 to start. So now start is 2. And we're going to keep n the same. So 2. All right. So what is that going to do? Well, that is going to, this call to subset ABCD with 2, 2 is going to trigger this base case. All right, if the base case gets triggered, that means we're going to return index of list of start. Well, start now is 2. So index of list of start is going to be 0, 1, 2. It's going to be C. So that is going to be then returning C. Okay, this call over here is going to return C. So now, oh, sorry, list of C, because an index returns a list. So that's going to return list of C. So now when you take that B and you cons it with the list of C, oh, I'm sorry, it's going to just be, it's just going to be, I gotta leave that one. It's just going to be not a list of C, but it's just going to be C. So when you take the B and you cons it with the C, those two atoms cons together, we're going to be left with a list that is B, C, and, oh, sorry, a list that is B, C, and that's what's going to get returned. All right. So assuming we did this all right, why don't we run this and see what happens? All right. So let's see. Let's do a debug. Get it all compiled first. Scroll down here a little bit. And I can set a breakpoint here, which I'm going to, and I can set a breakpoint here, which I will do. Say debug. All right. So we're going to say subset of, I'll just copy this. All right. Pause at this breakpoint and, ugh. Okay, let's try this again. Debug. Set 2 breakpoints and run subset. Okay, so we're starting out with the thing you need to pay attention to is start and end. List always stays the same, and we're just using index to go after particular values in the list. All right, so the first thing we're going to do here is start equal to end? It is not. So we're going to make a recursive call, but first we're going to extract index of list of start. We won't actually see what that value is just yet. And we'll let that run to get its results. Okay, so index of list of start is going to return B. Okay, so we just returned B. It'd be nice if it would show you what that value is. Oh, that's cool. It looks like I can see the value of the variables by just putting my cursor over it. Okay. All right, now that we have index of list of start, which is B, we're going to do subset list of start here, start plus 1. And the subset of list of start is going to get us C. If you look, start and end are equal to each other. And so that's kind of cool, as we evaluate these expressions, we're going to do another index here. Uh-oh, looks like I ran into a little bit of a problem. Oh, because I said list of start. Oh, I mistyped that. Okay, let's try running this again. All right, stepping through here. All right, index list of start. So we'll step through that. And just trying to get through that code. Okay, so now we've got index of list of start, which, like I said, that is the value of B. And now we're going to evaluate the subset of list and start plus 1, which is going to give us 2. I can see over here that I've got the expression being evaluated, which is great. So I can see what that is. I think I was missing that from this. Okay, and now we're back in here again. This time it says, hey, this expression that we just had would evaluate to true. So start is equal to end, that evaluated to true. And index of list of start, that is going to be, start is 2. So index of list of start is C. Okay, so we'll step through that. We'll let that index list of start resolve itself. You have to decrement pause by 1 to get that to work. And now we'll return C. And now we are going to cons. It says that this subset call that we had right here, the subset call returns C. So now we're going to cons this index list start value, which was B, with subset list start plus 1, and that was C. And okay, it looks like we have a little bit of a bug here. Okay, so we need this to be a list. We need a list. So, and okay, and now I see in my notes how we fix that. So we can make the base case return a list. And so the way you do that is there's a list argument. So the problem with cons is cons expects an item to be inserted into a list. Oh, but it's the second item that has to be inserted into the list. All right. So how do we make that work? I think we should be okay. Yeah, I think we're okay here. All right. So let's, we'll just rerun it. Now, this should work. I just had one bug, which is that the base case was not returning a list, but now I made the base case return a list. So let's paste that in again. And now we've got something that looks good. All right. So we said A, B, C, D, that's our list. I wanted a subset of list from B to C. Well, it's from 1 to 2. This is position 1, this is position 2, and that gives us the list BC. Let's try it again, but we'll change it from 1 to 3. Whoops. Okay, so now we're looking good. Now, I could add a little bit of debugging here and just say, hey, if we end up with a situation where, if we ever up with a situation where start and end, where start is greater than end, that's bad. Let's just return an empty list. Or I could return -1. All right, so let's try that. One, 4. So this, let's see what happens when I do that. Oh, okay, I return -1. That -1 is from a bad index. Let's see what happens if I return 3, 2. Where start is greater than end. Okay, it returns the empty list. Okay, well, it's not beautiful and perfect, but it's pretty good. We've got a decent working subset. All right, let's try another program then. And this is a program that will reverse a list of elements. So we're going to call this the reverse function. So let's do an example of what that looks like first. So if I say reverse A, B, C, what I get back is C, B, A. All right, if I say reverse A, B, C, D, E, what I get back is E, D, B, C, A. Okay, so define reverse. Okay, so that's the idea of it. So I'm going to start working on the code to do this. I want you to try to do it as well. So the way that you want to think about doing this is think about um, building a list by inserting stuff into the list backwards, basically. All right. And so if you can use the index function, you'd probably be able to get this to work pretty well. All right. Cool. Give it a shot. Now, oh wait, before you give it a shot, there's one more thing. So you can find out the length of the list. This could be really helpful too, A, B, C. That's a nice method for finding the length of the list. Okay, hit pause, give it a shot. All right, and now let's see if we can work on a solution here. So we'll call it reverse. It's gonna take in a list, and that's all we're gonna have for arguments. All right, now we're gonna have a base case. So I think what we should do is say if the base case is that we have a list with the size equal to 1, well, maybe 0. I don't know. I have in my notes 1, but there might be a reason for that, but let's go with 0. I like that even better. So if the base case, if we have a list length that's equal to 0, then what we're going to return is just return an empty list. All right. The recursive case is a little bit more involved. So for the recursive case, what we'd like to do is we'd like to use the index to pull out the last item in the list. All right. So that's what we want to do is we want to use the index function to pull out the last item in the list. So what is the last item in the list? Well, the last item in the list is, oh, and we're gonna pull that out, and we're gonna take that last item in the list, and we're gonna insert it into a recursive call to reverse with a slightly smaller list. That's the idea. So pull this item out, insert it into a new list that's being built up using these two, a reverse of, sorry, let's say this, pull this item out and then insert it into a reverse of the list with these two items. Pull this item out, insert it into a reverse list with just this item. And then pull this item out and insert it into a reverse empty list. That's the base case, which returns an empty list. And so all the items end up getting inserted into an empty list. Okay. So we're going to use else and cons, and we're going to construct a list out of two parts. The first argument is always an atom, and the second argument, typically an atom, can be an atom or a list. The second argument always has to be a list. So we're going to take index into list, and the value that we're going to pull out of the list is the rightmost element in the list. So if we take length of list. That'll give us the total number of elements in the list, but we actually have to subtract 1 from that to get a 0 indexed value. So, whoops. So length of list minus 1. All right. So the length of list minus 1, if the length of list is 3, minus 1 is 2, that's index position value 2. That'll extract the C. All right. Now, we're going to take that single atom or single value extract from the list, and we're going to insert it into the continued reversal of the list. And what we want to do is we want to pull out all of the elements from here to here, except for this element, all right, except for that last element in the list. So how do we get these elements? There is a rest, which will get us everything after the first element. There's a first, which will get us the first thing in the element. But how do we get everything up to but not including the last element in the list? Well, we can use index to do that. So if we say, or sorry, we can use subset. If we say subset list 0, so that'll start us right at the beginning of the list. And then we're going to go to what? We're going to go to length minus 2, right? If we go to length minus 2, that'll get us everything but the last element in the list as our index. Minus length list 2. All right. Okay, well, let's see. Okay, so we'll call it rewind since it's a defined reverse. We'll make it with the Z. Okay. All right. So let's try reverse A, B, C. All right, we get list CBA. And let's try a little more of an interesting list. A, B, C, D, E. Okay, it looks like it did the reverse properly. So what's one observation here? Well, I would say that building up your programs, functional programs, by using other functional programs that do small things that you can kind of mentally wrap your head around is a really good way of building useful functional programs, especially when you're starting out. So we built a real simple function at first called index, and then we built subset using index, and then we built reverse using both subset and index.